All right, so today we are discussing Chapter 5, Lesson 6. We're going to be solving systems of linear inequalities. So the objective for today is to graph and solve systems of linear inequalities in two variables. All right, let's go ahead and get started. So first we're going to start with just a little bit of vocabulary. So, a system of linear inequalities. So far in this chapter, we have talked about systems of linear equations, and we've also talked about, in the last lesson, inequalities. So now we're going to put the two together, right? So a system of linear inequalities means we're going to, instead, like in last section, we were just talking about one linear inequality. Now we're going to do a system, which means we're going to be doing two. So a system of linear inequalities is a set of two or more linear, which linear just means it's like a straight line, two or more of linear inequalities containing two or more variables. All right? So the solutions of a system of linear inequalities are all the ordered pairs that satisfy all the linear inequalities in the system. Okay? And really keeping on that idea of solutions, that's how we're going to get started with the first example. So we're just going to be looking at how to identify, oh wait, check it out, this is the wrong one, right here. How to identify a solution to a given system of linear inequalities. So it's really similar to what we've been doing before. So I think this is you're gonna catch on pretty quickly, and it's gonna be a little bit of review for you. So basically, what we wanna do is we wanna figure out, is this ordered pair a solution to the given system? It has to be a solution to this inequality as well as this inequality. So what we have to do is we have to substitute this ordered pair into both inequalities separately, right? So I'm taking this ordered pair and I'm going to substitute it in first to this inequality, which is written right there, and then second, I'm going to substitute it into this second linear inequality right there. So you basically have to do it twice. So when you're doing a homework or a quiz or a test and you only do it once, you're going to get it wrong. You have to do it to both for this system, okay? So this right here, this is my x and this is my y, just like any regular ordered pair. And I'm just going to substitute those values in. So I'm going to put -3 for y here. -3 multiplied by x, which is -1, plus 1. And then I'm just going to simplify, okay? So order of operations says I have to do the multiplication first. So -3 times -1 is a +3 plus 1, which is 4. So I'm going to ask myself, is -3 less than or equal to 4? And the answer is yes, it is. This is a true statement. You have to say what this means. When you say true, this means yes, this ordered pair is a solution to this inequality, okay? But for it to be a solution to the system, it has to be a solution here, and it also has to be a solution over here. So we have to check this one as well. So this is a true statement. You can't just say true. You have to actually answer the question, all right? So we have to figure out x and y. So we're going to substitute that in. This is -3 less than 2 times x, which is -1 plus 2. And then just order of operations. 2 times -2, -1 is -2. And we're just simplifying. -2 plus 2 is 0. Now we want to ask ourselves, is -3 less than 0? And yes, it's true. Now, if this is all you have, then you're going to get it wrong because the question is asking you to tell whether the ordered pair is a solution of the system. Did you say that? No, we haven't said anything. I'm just going to pretend like this isn't there. We haven't said anything. So now, since we know that the ordered pair makes a true statement here and this ordered pair makes a true statement here, we can say, yes, -1, -3 is a solution to the system. Okay? So that's how you get full credit. You show all the work and then you answer the question. I just feel terrible because sometimes people do these and they just leave it at true and true. And it's like, you know what? You didn't even answer the question. You have to read the directions and answer the question. Okay? So you have to answer yes, the point is a solution to the system. Okay? Let's look at this next example here. Okay, so it says tell whether the ordered pair is a solution of the given system. So here's our ordered pair, here's our system. So again, we have to take each individual linear inequality and put that ordered pair into both of them. So here's our ordered pair. So it's written, and then we're gonna do the first linear inequality here. And then we'll do the second one right here. So remember, you have to do this twice. I feel like my highlighting skills need to improve. Whoa, what's wrong? Okay, there we go. Perfect. Okay. So this is my x, this is my y. I'm going to substitute those values in. So instead of y, I'm going to write 5. Negative 2x is negative 1 minus 1, right? And then we're just going to finish it. Negative times a negative is a positive. Then we just simplify. 2 minus 1 is 1. Is 5 less than 1? No, it's not. This is a false statement. So really at this point, we know that this is not a solution to the system because it would have to be true for both and it's already false, but I'm going to go ahead and finish it over here. And so this would be 5 and that would be negative 1 plus 3. Simplify would be 2. 5 is greater than or equal to 2. That is a true statement, but still you have to answer. So tell whether the ordered pair is a solution. So no. Let's say no, negative 1, 5 is not a solution to the system. All right, so that is it. So again, we have to show our work on both and then answer the question. All right, now it is your turn to check it out. I want you to check it out, example 1A and also 1B. And here's my friend. Where's my friend? Oh, there's my friend, the pause dragon. Remind you to pause your device, work out the problem. When you get done, press play and we'll go over it together. All right, see you in a bit. Okay, let's see how you did. So we have our ordered pair. We want to see if it's a solution to either one of these. So I'm going to write it here, the first linear inequality. Okay, and then my ordered pair is here. This is my x, this is my y. I'm going to go ahead and substitute 1 in there. And then my x is 0. And what do we have? Negative 3 times 0 is 0, 2. So 1 is less than 2. That's a true statement. That's great. So now I got to do the other one. Here's my ordered pair, substitute it in. This is my x, this is my y. 0 minus 1. Oh, shoot. Why did I just do that? Okay, forget that. 1, and this is negative 1. So is 1 greater than or equal to negative 1? Yes, that's a true statement. So I can say yes, I got to answer the question. 0, 1 is a solution to the system. There we go. We showed all the work. We answered the question. Awesome, awesome. So if you got that right, woohoo, great job. Let's go on to the next one. Okay. We're going to tell if this is a solution. So 0, 0. We got y is greater than negative x plus 1. So this is my x, this is my y. I put 0 here, negative 0 plus 1. That's basically 0 is greater than 1. false. That's not true. That is a lie. Okay. However, I'm going to do the other one. Y is greater than x minus 1, 0, 0. This is my ordered pair. 0, 0, minus 1. So we have a 0 greater than negative 1. Well, yes, it is. But since this is a lie, this is false, we can say no. 0, 0 is not a solution to the system. And that is it. If you got both of those right, you did a wonderful job, and we will see you in a little bit for example 2.